Hey guys, yes, I'm back. I don't know how long ago it was I did the last video, which was a cheat anyway. This is another cheat, and I just thought, because I've not put anything out for so long, that I'd do a cheat with this subject, which was the quill stop that I made quite a long time ago. I thought I'd go through that and shorten it down and just make it a more concise project, so it would be free of some of the waffle I used to put in. I haven't been out here much. We've had intense heat, which many people will have known about. Quite ridiculous heat. It's pretty hot now, but not quite the same. But still gets pretty tricky out here, but the back's the main limiting factor as usual. It only tends to get worse, but we'll hope for better things. So this is a condensed video, and I'll put a couple of, or 2 or 3 little bits on the end just for the sheer hell of it. So if you do get through the whole thing, stay to the end. I've got 1 or 2 clips, one of which I find very amusing. You'll see why. Anyway, without any further ado, I'll get on with this, which will probably be done in stages, so at some point I'll get the thing out and uploaded. Alright, that's it. Thanks for watching. Bye for now. Just an initial look at a CAD mock-up of what I was aiming to try and make, to give you some idea. And this is how it looked more or less when we'd finished. Give you some idea of what we were aiming at. So the first job here was to set up the beaten up old rotary table, trying to get it set up reasonably well. It's a pretty small error, actually worked out fairly well. Now the plate's been fixed, albeit rather basically. It was quite a job to hold it down, but it worked. 5/16 carbide end mill. In essence, we're trepanning, and I'm only taking a cut of, I think it was about 100 thou, maybe a bit more, but I had several passes, and it was just a long job, and you can see all the chips that were left. Keep vacuuming up at the end of each spell. Now taking a deeper cut, getting towards the end. As usual, a lot of chips to vacuum up. So check the diameter, see if we're getting close to where we want to be. Having aimed to finish up just a little bit short of the final, so we can take a finishing cut, which is what we're doing here. So we're going obviously full depth here, and getting the finish, which should be close to size, hopefully. Now we're going to cut the outside, and again the same milling cutter. Gradually work round. Again, incremental cuts. Patience is a virtue on this. It's more chips. And we've got to be careful here not to go too far. We've got to end up with what will be a fillet radius where we meet the straight sections. So now a finishing cut on one side and stopping short of that little radius there, which we'll clean up later. So there it is at that stage. We've still got quite a bit to do. We're going to do straight cuts with the bandsaw, get rid of that material, Now let's see if it fits. Yes, it fits, fortunately. And this end's going to be slit and set up for a pinch bolt. Bit more to do. Back at the bandsaw, get rid of the remaining material. Speed it up a bit like most of my clips in this. This is an old 3-wheel bandsaw which I've had for years, but it still works quite well. The cut was actually quite reasonable, surprisingly enough. Now let's look at the finished article. Although, well, finished, in fact, it's got to be filed all the way around and to generally tidied up, get the radius corners smoothed up a bit. It's quite a bit of work to do to finish it. And we've got to do some extra work now. There's going to have to be a hole here, which is very critical. That's going to be a 3/8 hole for the vertical rod, which also has to have a flat put on it. And then the other end, which I think I mentioned, we've got to slit that, drill across and tap to take a pinch bolt. Bit to do yet. So first of all, for the pinch bolt, we're going to drill through there, tapping drill first all the way through, get that started, and once that's done we'll set up for counterbore. Going to use a cap screw. This is a very old counterbore I've had for ages. It actually works reasonably well for some jobs. Anyway, this one, it suits quite nicely. And then once we've got that done, just check and see if it is deep enough, which it is. It's more or less adequate. I'm trying to get away with an inch bolt instead of 1.25 inches. Finally go down to the line with a clearance drill. Which doesn't take very long. And then set up for slitting. And this slitting saw is a bit coarse actually for my liking, but it was what I had available. I could only just clear the spindle, but we got away with it. It actually came out fairly nicely, all things considered. Incidentally, if you happen to hear a rooster, my neighbour's got a darned rooster. You might just hear it, I don't know. So there we are, another stage done. You can see the pinch end. Still mentioning about cleaning up needed, and the spring actually is quite reasonable. If you look, you can see the amount of spring in there, so the pinch bolt's going to take it up quite nicely, I think. So on to the next stage, which is pretty critical. So this is the plan. We've got a piece of 1/8 going up the side of the machine to make use of 2 holes. I think they're M5. But it's very critical to find the position in the spindle yoke collar for the vertical rod, which is going to go all the way up, probably plus a bit. And that's got to be dead true. So it's really quite a critical stage. So I've had to mark through, mess around and mark through to find the exact position for that. One of the more critical aspects of the whole thing. Now the guide block has got to be fixed to the bottom of the 8th piece of bar, and I'm going to bolt that from behind with a couple of 1024s rather than try and weld it. So we're going to make the half-inch rod. First thing is to turn down the end so we can put a thread on it to go into the end of the yoke. Just turn that down, and then to put a thread on it, well, I tried a rather crappy die which actually was extremely ineffective, so I decided to pick up the threads and single pointed instead, which was a lot better idea. The die was very hard work. As you can see, it made a start, but very often single point is the way to go. Now we've got to see if the nut will fit. Sorry about focus. My autofocus always looks at the chips in the tray rather than the workpiece, but anyway, the nut fits, which is something. Now we need a flat on the rod to nominal 60 thou, which obviously then gives us a surface for the locking knob to bear on. Pretty much adequate really for the job. Having marked up the spindle collar as carefully as possible, just use a centre drill to spot that, and there's a 3/8 hole which has already been done. Now we move on to the locking block. Set that up, and that needs a 1/2 inch hole, so we'll put a 3/8 through first, get most of the meat out of it. It's a bit easier than going straight up to 1/2 inch, and then follow with the 1/2 inch, reduced revolutions, bit of anchor lube, and get that out. The next job is actually, we've got to fix that guide block to the 1/8 inch piece of plate bar. So I opted here to use some CA glue because it needs to be set up absolutely dead square. Bit fiddly, but got it clamped up and then left the glue to cure, after which we can go back to the mill and drill tapping holes for the 1024s. Not a very complicated job, but unfortunately the glue held alright. I think I've gone a bit past where I needed to go there. Alright, back you go. Finish off the other hole. Now the next job is to fit the 8th bar to the machine, which is going to be very critical. We've got to maintain good verticals so we get a good sliding action with the rod. And the 2 holes, which I think are M5, I put a couple of transfer bolts in, but then in order to make use of those I've got to make a small, or have made a small piece which is 3/8 by 1/2, and by putting that in it leaves me clearance so I can use the hammer. Loosen the collar a bit. What I didn't notice initially was that I'd let it drop, so this is actually the second time round. having screwed up one time. So we're going to finish up with 2 marks, which is not a problem as long as I drill the ones that matter. Just take that off and inspect, see what we've got. Transfer bolts are an absolute blessing sometimes. Right, there we are, 2 sets of holes. So we're going to drill the bottom set. So get those drilled out. You can see the guide block fitted on the bottom now. So in position, actually bolted in position. So, and that bottom cap screw will probably have to be replaced for clearance for the locking block a bit later on. Main thing is to see if the piece of rod slides freely enough. We'll do the nut up finger tight and then see what happens. That feels free, which is a bit of a relief. Yep, not too bad. Now the rod's only finger tight at the moment, which is adequate for test. It'll have to be set up properly later. Now we've put a countersunk. It's not quite flush because it's only the 8th piece of bar, but that'll make sure it clears the locking block. Now the locking block just needed a bit of a tidy up, so decided just to do a skim on the important edges. Again, not overly critical, to be honest. So there's the block, just tidied up a little bit, and that's got to have some holes put in it. We've got to have a central 1/2 inch hole, and then a hole at the end tapped, I think it'll be M8, for the locking knob. Get the centre hole done, same as before, 3/8 pilot, and then put a 1/2 inch down to finish off. Next step is tap the hole for the locking knob. As I say, I think it was M8 that I used. Incidentally, sorry if you hear the odd weird noise now and again. It creeps in. Power tapping didn't work because the chuck wasn't holding, so I in fact just backed off and then later on finished it by hand. Now, instead of soldering a brass pad on the end of the locking knob, I'm actually using some ultraviolet curing plastic. I think this one was called Bondit, but there have been more than, well, 1 or 2 versions, I think, and the idea was to avoid bearing metal on the sliding rod. It's quite a clever system, and I can't remember whether it actually remained bonded. I think it did, but later on I actually made a different knob so I could get better torque on it. So there's the locking block, ready to go. Finally, time to test the whole setup and see what repeatability is like, which turns out to be not too bad. Set it according to the ZDRO, locked it up, checked for repeatability, which was actually, I think, if I remember rightly, only about 1/2 thou, which wasn't too bad. Got to be careful, of course, with this setup that you don't get any bits between the 2 blocks. Just a case of checking that visually before you actually set it up for use. So a final look, bit of handheld camera just to show it from different angles. Worked out quite well. I did actually later on make a new knob, which I may have mentioned, because I couldn't get enough torque on this one to get a reliable tightening, and the collar's not quite finished on the internal radius, but not really a problem. It's only aesthetics. Yes. And I've got my Angel Eyes LED ring back in place. Overall quite pleased with the end result. It's been put to good use since I made it. It's definitely a worthwhile modification, although quite a lot of work. Just the extras. Local fire hall event, mid-July. Fireworks to finish, and then my little grandson.